we will talk about 1 or 2 sample estimation problems. Okay, we will talk about estimation of the mean or proportion, and we will talk about the confidence interval. Okay, these are the 2 things that I will mainly focus on. What does confidence interval mean? How can we estimate the confidence intervals? What do they used for? Okay, so let's start with this question. Now I want you to write on the chat your answers. Okay, let me read the question. Let x1, x2 up to x64 be independent observations from a distribution y which is not normal, like chi-squared, exponential, uniform. Okay, I have data from a non-normal distribution. Suppose it is known that the mean of this distribution is 45 and the standard deviation is 8. What can we say about the sample mean x bar? That was a question from a final exam a couple of years ago. Okay, suppose that the mean is this 45, standard deviation is 8. What can we say about the sample mean x bar? Okay, now I want you to think about this and give me the answer in chat. Slide from the last week. We have a population, and the mean weight for the population is 170 pounds from Britain. Okay, and then I take one sample in which there are 64 data, and like 64 people have different weights, and the mean x bar means sample mean is 173. I take another sample, again 64 people, I get another sample mean. I take another sample, I get another sample mean. Is that possible? That is possible, right? So we can choose from a population, and out of that population that I might get different sample means. Okay, what does that mean? This whole thing means that the means are distributed according to the normal distribution. Okay, sample means, these are sample means. Okay, sample means are distributed with respect to a normal distribution whose mean is the mean of the population, whose mean is the mean of the population. You know, this is normal distribution n, this is mu, and this is sigma. This is the mean, and this is the standard deviation. Okay, so what do I say for this distribution? The distribution has a normal shape or Gaussian shape, and the mean of the distribution of the sample means, I plot this, I plot this, I plot this, I have this kind of a histogram or distribution. Okay, what does this distribution tell me? The mean of this distribution is the mean of the population. Okay, what is the standard deviation of this distribution? It's going to be the standard deviation divided by square root of n. Okay, this is the population's standard deviation. This is the sample size, how many people I'm getting data from, sample size. Okay, and then what does that mean? I have a normal shape, and I have the population mean is mu, and I have a new sample like distribution of the sample means have a normal shape, and the standard deviation is sigma over root n. Okay, so now let me go to the next slide. And what does it mean? Means, this is called central limit theorem. We will use this a lot. Okay, means based on large samples will have a normal sampling distribution. Okay, means based on large samples. So I have a population, I'm taking samples. Okay? And then I'm obtaining X bar 1, X bar 2, X bar 3. What is X bar? Mean of that sample. Mean of this sample, okay? There are 1,000,000 people here. I take 1,000 people, 1,000 people, 1,000 people, and I obtain different sample means. And then this sample means are distributed according to the normal distribution. Sample means are distributed according to a normal distribution, okay? And the mean of this distribution of the sample means is going to be the mean of the population, okay, equal to the population mean with a standard deviation equal to the standard deviation of the population divided by the square root of the sample size. This is called standard error of the mean, okay? Normally, I have in my population, I have this distribution, mu and sigma. When it comes to the mean of the samples, the distribution is going to be even sharper, okay? And then the mean of this, the distribution of the means is going to be the same. This is going to be the same, okay? This is the population distribution. This is the distribution of the sample means. Why do I need that? If I have, I'm trying to estimate. My goal is to estimate the sample mean, okay? I am trying to, or the population mean actually. I take a sample, I look at the mean, and I'm trying to understand what is the population mean, okay? I'm trying to infer, I'm trying to deduce some things about the population. What is the population's mean? Okay, in Kayseri there are 1.5 million people, and I would like to estimate one parameter. Let's say average income, average rental rent, average let's say number of rooms in their homes. Okay, these are the things that I would like to have at the end in order to do my let's say marketing strategy and so on. Or I would like to find out something about in the production line or in my telecommunication system, and I would like to obtain a sample and try to estimate something about the population itself. Okay, so that's the main idea. So we are trying to estimate population mean, okay, by using a sample or the samples, okay, estimate population mean and using a sample. Now I obtained, let's say I obtained this sample, 173. What does it mean? Is it exactly the same thing with the population mean? It may not be, or it may be, I don't know. I don't know this one. Okay, I don't know this one, and I cannot go and take infinitely many samples and obtain this Gaussian shape, but I have only one sample like this, okay? And I would like to comment on the probabilities using this sample, okay? I would like to say something about the population mean itself. I'm going to say from this sample, the mean is 173. But is it a good estimate? Should I take another sample, or what can I say about this estimate? Okay. Emmanuel asks, Hocam, so we can get a normal distribution of the mean from a non-normal distribution. Exactly. That's the point, Emmanuel. That's the point that I would like to make. Even though this population has a uniform distribution or exponential distribution or chi-square distribution, I don't care whether they have any form of distributions, but the sample distributions of the mean, okay, the X bar is has a normal distribution. Okay, I will take a sample, another sample, another sample. Those samples the means of those samples will have a normal distribution. That is central limit theorem. Okay, I'm planning to ask a question about central limit theorem. Your understanding is very critical in statistics about the central limit theorem. What does it mean? Here is the definition. Okay, the central limit theorem says I'm gonna get large samples from my distribution, and then the distribution, whether it is normal or not, I don't care. The means will have a normal distribution, and this normal distribution's mean is going to be equal to the population mean. Okay, so I'm trying to guess what is the population mean, right? What is the number of rooms in Kayseri homes? Okay, what is the number of broken or defective parts in let's say in one of the factories in Kayseri? So I'm trying to guess this, the whole population, using the samples. The sample means have a normal distribution, and this normal distribution has a mean of the population. Also, the standard deviation coming from the population, we will assume that either we will be no sigma. Okay, we will have two cases. We will call this Z interval or Z test. Okay, Z interval or Z test, and in which sigma will be known, and we will have another one, T test. Sigma is unknown. I don't know the population standard deviation, or I may know it from my previous knowledge. Okay, if I know it, I'm going to say, okay, the standard deviation of the mean distributions, okay, distribution of the means is going to be the standard deviation of the population divided by the number of samples I have. Okay, if I have, let's say, 10 samples or 100 samples, which one is more sharper, guys? If I have n equals 10 or n equals 100, that means I have 10 data in my data set, or 100 data in my data set. Which one is 1 and which one is 2? For n equals 10, 1 or 2? Okay, this is the mean of the population, and this is the standard error of the mean. Okay, please write to chat. What do you think? And if n is equal to 10, is it going to be sharper, or 100 will be sharper, right, guys? 100 will be sharper because I have more data. If this is 100, that means I'm going to divide sigma by 10. If it is 10, I'm going to divide sigma by 3. So the 100 case, if I have more data from my population, if I have more data from my population, my error will be less. Okay, that's the point. If I collect more data from my population, my error in estimating the mean of the population is going to be less. Understand? Arkadaşlar, burası önemli. If I have more data from my population, I will have a better estimation, right? So if I'm going to ask what's the overall GPA, a mean GPA of the whole college students, I'm going and asking only 10 students. Or I'm going and asking 10,000 students. From which one will I get a better estimate of the college students' GPA or mean GPA? For sure 10,000, right? If I can go and ask million students, it will be even better. Okay, that means large samples. Okay, so one thing, if I have large enough samples, and then I will have a better estimation. But in many cases, for example, in medicine, in biomedical applications, you don't have many samples because they are very costly. You cannot obtain thousands of data. You can only have 100 patients or 150 patients to work with. Okay, but if you're going to see this, if the limit is, if the n is more than 30, we will say if we have large enough sample. Okay, so the number 30 is a critical, very important number. So let's go back to the question again.
Hocam,
Yes.
can I ask something?
Sure, please.
If we know sigma, and also we have sample size less than 30.
Okay.
What we're gonna do, because both of them are not rule of the Z.
We will be doing, again, it all depends on the distribution, okay, but we can do Z again, but we have to be careful. If it is less than 30, we have to be careful about the distribution of our data, okay? We have to check whether it has a normal distribution or not, okay? Let's check our data in that case, if it is normally distributed or not. If it is not normally distributed, then you have to go to the non-parametric tests, okay? But if it is close to 30, you can assume that it is normal, and you have to be cautious in let's say analyzing or commenting on your findings. Okay, so it is usually critical that you have more data than 30. If you have less than 30, you will do a kind of normality check. Then if it is normal, you can go with the Z test, okay, or Z interval. If it is not normally distributed, your data, then you can be, and it is less than 30, it's like 20, 15, then you should go to the non-parametric tests. Okay, you have the data. If it is more than 30, then you go to the Z test. Okay, if sigma is known. If it is less than 30, again, check normality. And if it is normal or close to normal, being normal, then do Z test. If it is not normal, non-normal, then go to the non-parametric alternatives. Okay? There are non-parametric alternatives to Z test. We will mention them in very close to the end of the course. Okay? Is this clear?
Yes, hocam.
Okay.
Also, if we, for example, we are saying that non-parametric, right?
Yes.
But from the central limit theorem, I guess it's name correct.
Yes. Yes.
Mean of the mean is always normal, right?
Means, the distribution of the means, is normal. You see, distribution of the means. If you take many means, like you have this population, you take samples, and you find the means from each sample, and you take the histogram of those samples, you're going to get a normal distribution, whose mean is going to be the population mean. Okay, but
and if it's smaller than 30, it's still normal distribution, right, hocam?
If you have large samples, that's very critical. If you have enough large samples, okay, for example, if you have 10 sample from here, 10 sample from here, that's the problem. For example, if you have many samples, like 10 sample, you have this population, and you have smaller samples, okay? So in the final case, you're going to have the means like this, but you're going to have something like that, a more spread distribution. But when you look at the data, this 10 data, this data may not be relevant to the normal distribution. It may have a chi-square distribution or something like that. Okay, so you're going to do something on this 10 data, for example. You have 10 data from your population, only 10 data or 20 data. You're going to either assume that it is coming from a normal distribution, for example, weights of people, heights of people. This is a normal distribution normally. You can assume that it is normal distribution and you can do the z-test. Or you don't know what's the underlying distribution. The distribution's mean is going to be, means distribution is going to be Gaussian, but you have to check the distribution of this sample also. Okay, so they may be a little bit different in that case. So you don't know what the underlying distribution is, but you are checking only 20 samples, and this 20 samples might have a different distribution, and you're trying to find out the mean of this distribution. You don't know anything about the distribution itself. So the large enough sample size, if you remember, that was the large enough sample size. Central limit theorem says if you have enough big samples, like more than 30, then you can immediately do this normal sampling distribution kind of assumption. Okay, but if it is not large enough, you may not have a normal sampling distribution. Then you have to do, you cannot work on these central limit theorem based theories. You have to go to non-parametric tests then. Okay, that's the critical part. Large samples, based on large samples. If you have smaller samples, then you cannot do this central limit theorem based assumptions. Is this clear?
Yes hocam, thank you so much.
Arkadaşlar, now I have 64 observations, 64 data. Distribution of Y is non-normal or not normal. What can you say about the mean X bar? Now I want you to write to chat what can you say about sample mean X bar? Thank you, Süleyman. Emirhan, good job, good job. So our sample mean has a distribution, normal distribution of 45 being the mean and sigma over 64 root 64, sigma is 8. Okay, then it means n 45 and 1 is going to be my distribution of the sample mean. Okay, so I can say that the mean sample mean X bar, okay, from that observation, okay, it is coming. I cannot say Harun Rashid, I cannot say that it is exactly, the X bar is exactly 45. I cannot say that. But I can say this X bar is coming from a distribution whose mean is 45 and whose standard deviation or standard error of the mean is 1. Okay? Is 68% of the time, okay? 68% of the time, our data will be 45, 44, 46. Okay, 68% of the time, the mean is going to be, or the probability of obtaining a sample mean between 44 and 46 is like 68%. Okay, let me go back again. Probability of obtaining my X bar, okay, or the mean, okay, let's say probability of X bar being between 44 and 46 is going to be equal to 0.68 or 68%. Okay, so how do I know that? The 68 is a kind of rule of thumb. Okay, one mean minus standard error of the mean. So this is my distribution: mean plus standard error of the mean minus standard error of the mean. This area is going to be 68%. If it is mean minus 2 standard error of the mean, it's going to be something like 85%. Okay, so what does that mean? The sample mean x bar will have a normal distribution whose mean is going to be 45 and whose standard error of the mean is going to be 1. Is that clear, guys? Did everybody understand what I tell you? Okay, now I want you to write what I told you in a minute, in the last 1 minute. What is the answer? What can we say about the sample mean x bar? I want an answer from all 48 students right now. Again, I will record now. Okay, guys, now we have, we will talk about confidence intervals. Okay, confidence interval. We were trying to find out the estimate of the population using our x bar, right? So we say that this is the estimate for the population mean. I would like to find out this, but I have this in my hand. So I'm trying to find out, estimate using this, and I'm trying to find out this one. Okay, I don't know this one, and I know this one. From this, I would like to go and estimate. Tahmin ediyorum. Kestirmeye çalışıyorum. Okay, I'm trying to estimate the population mean using the data that I have in hand. Okay, so population mean is not known. Population proportion is not known. What do I have? I would like to, for example, determine the proportion of college students between 18 and 20 who own a car. Okay, that's one thing that I would like to estimate. I cannot go and ask 5 million college students in Turkey, and I can go and ask it to a certain sample and obtain data from the sample. So we may have mean number of days it takes first graders, ilkokul yeni başlayan çocuklar, to learn how to read and write. Okay, so the number of days, for example, this is something that I would like to estimate. This is something that I would like to estimate. How can I do that? I can take a random sample and see the data and then try to understand the general mean of, let's say, or proportion of these topics, right? Unknown, like ages, who own a car, the proportion of Turkish college students, the number of days. Okay, so I cannot go and find exactly I cannot go and ask all the people in the population, and I would like to come up with a good estimate. So here is what we are trying to find out. For example, mean GPA of college students is between 0 and 4. Okay, this is called parameter space. Okay, and P, the number of the proportion of students who smoke cigarettes, is going to be from 0 to 1, right? Because this is proportion, this is percentage. Okay, so these are like parameter space, and we may have point estimators. Şimdi we want to find out mu or P. Okay, how can I do that? I can go and sample, perform a sampling, and obtain a mean of the sample, right? This is called point estimate. I'm telling one number, 64 is the mean point. 64 is the mean that I found, okay, from my sample. But I can do it again. The proportion estimate is going to be I'm adding up, like I'm asking, do you smoke? No. Do you smoke? No. Do you smoke? No. Do you smoke? Yes. No. Yes. No. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I have 10 answers from 10 people, and I'm trying to find out the proportion from my sample. How many people are smoking, right? How many people? 1, 2, 3. So I'm going to add up 0, 0, 0, 1, 0, 0, and I'm going to add up to 3. This is going to be, this whole thing is going to be 3 divided by 10, which is going to be, the proportion is going to be 0.3 or 30%. This is a point estimator of the population proportion. You understand this, right, guys? These are the answers from my sample. Yes or no kind of answers, and I'm adding up all yeses and then obtaining a number and then dividing by the number of people I'm asking. Okay, so another thing, we will be estimating the standard deviation or variance. This is something that we will use very soon, 1 over n minus 1. Again, this is the definition of, again, the variance. The variance is like the distance between our data and the mean of the data, and then taking the square and adding up and dividing by 1 minus n minus 1, or 1 over n minus 1. These are all point estimators, okay? Point estimator. That means I'm having one number, but I gave these examples over there. But instead of using a point estimate, I can find an interval like we did previously, right? We said it's going to be between this and that, most probably. Okay, so we would like to estimate an interval in which, with some confidence, I will say that my mean is in this range. Okay, I'm going to say this is my sample mean, and there is a lower bound and there is an upper bound, and with some certain confidence, I'm going to say that my mean is in this interval. Okay, so we can be really confident that this interval will contain the actual unknown population parameter. Population parameter means mu or proportion or the standard deviation. Okay, so but we will mainly focus on the mean for the sake of completeness. Okay, I'm going to just talk about mu in this class. So here is the thing that I mentioned to you. Okay, there will be a lower bound or upper bound, and there will be this mean or proportion will be in this interval, right? Interval means aralık. It is between L and U, and with some confidence. Okay, I'm going to talk about that, and this is called the confidence interval. Okay. So I'm going to talk about confidence interval with respect to alpha. For example, I'm going to say alpha is going to be 0.05, and my confidence interval or confidence level will be 95%. If alpha is 0.1, I will be saying my confidence level is 99%. If I have 0.10 as my alpha, okay, and these are my confidence levels, it's going to be 90%. Okay, 90%. So we will be talking about these 95, 99, 90 in your projects. You're going to be doing these confidence intervals. Okay, so let me check the time. It is 9:40. It's 15 minutes. Let's have a 10-minute break at this point, and then we will be talking about. Let me have one more minute, and then we will have 10 minutes break. Okay, okay, guys. So burası biraz önemli. Bir odaklanmanızı rica ediyorum. So again, you're going to use this in the project also. So you're going to find out an interval, okay? You're going to find out an interval, and then it is like a lower bound and upper bound. And you're going to say that I am 95% confident that the population mean falls between L and U. Okay, this 95% confidence level will really be important for me. For example, I'm going to say I am 99% confident that my mu is between this and this, or I am 90% confident that this L and U is this, and my mu is going to be here. Okay, I cannot know the exact mu at any time because I will not be able to go and ask millions on millions of people, or I will not be able to test millions of parts. But I'm trying to estimate a certain confidence, a certain interval with some confidence, saying that I am 95% confident that the population mean is in this interval. Okay, in today's session, we will be talking about what does this 95% confidence mean? Why did I come up with a larger interval like that for 99% confidence? Why did I draw a smaller interval with 90% confidence, and this is 95% confidence? Okay, so the confidence interval is something that most probably includes the population parameter with some probability or with some confidence. Okay, that's the point of today's session. Please make sure you attend the next one, because we will be talking about what does this whole thing mean. We will have a 10-minute break right now. Let's meet at 10:45. Okay, 9:45. 9:45. See you in 10 minutes, inshallah. Okay, for example, guys, I have, let's say I'm clearing my my workspace, and I have let's say I have a variable. Okay, it is a normally distributed random variable, and I will generate like 1 million numbers. Okay, this is 1 million numbers. Now I'm gonna plot it, histogram of A. Okay, this is my histogram, right? This is the numbers that I have generated, whose mean is 0, whose standard deviation is 1. That is what rand function does. Okay, now I'm gonna find out how many of these length of find A less than, okay, 1.96. Okay, where does this number? I will tell you. Okay, so I am trying to find out how many of these 1 million data points that I have are greater than this 1.96. Okay, so for example here 1.98, 1.96 is somewhere here. So I'm trying to find out how many of these are coming from this part of the values. Okay, so 25,000 out of 1 million data values are greater than 1.96. Okay, 25,000, that means 0.025% of my whole 1 million numbers are greater than 196. How about if I want to find out how many of them are less than 1.96? This time I'm trying to find out how many of them are in this region. Okay, and then it will give me a similar number. but not exactly the same. It will be almost 25,000 numbers, okay? That shows me this normal distribution, the histogram of my normal distribution has a 0 mean, 1 standard deviation, and 0.025% of the whole area is in this region, and 0.025% or 2.5% of the whole area is less than this and greater than this. Okay, so what does that mean? I may obtain, let's say, let us obtain a sample from this A. Okay, let me generate integers. I'm gonna generate integers like round E. How am I doing that? How am I gonna do that? Round E. What should I do? I'm gonna generate integers, uniform distribution from 1 to 10, 100 of them, right? So I want to generate a number between 1 and 1 million and 100 of them. So B is going to be round I 100, 1 million numbers. From 1 to 1 million, I want to generate 100 numbers. Okay, so these are 100 numbers that I generated. These are the indices to each data point. Okay, now I'm gonna go and find out the mean of those 100 points in my distribution. Okay, I had this distribution. Now I chose 100 samples from that population. Now I'm finding out the mean coming from 100 people, okay, or 100 values. So I found that it is minus 0.0841. What is the actual mean of the population? It is 0. But this value is close to 0. Let us say I'm going to generate another set of 100 values. I'm going to choose another 100 people. And I'm going to find out the mean. It is 0.21. Now, the mean is coming from this part. Okay? So the means from different hundreds individual observations may be different, right? So by obtaining these means, I'm trying to talk about what is this is my estimate for the population mean, but in confidence interval, I'm going to say it is between this and that with some certain confidence level. Okay, is this clear what I did right now? Is this MATLAB thing made you think about some things better, or no meaning for you? Which one? Arkadaşlar,
hocam.
bu yani ne yaptığım anlaşıldı mı acaba? Ne yaptığım anlaşıldı mı sevgili arkadaşlar? So this is what I'm trying to tell you. Okay, I have a distribution which is normal distribution. If I choose a value, from this distribution, this is 0. Okay, if I say I have millions of data and 0.025% or 2.5% of the whole data is from this area, right? Yani ne dedik? The height of AGÜ students. The mean is, let's say, 173. But can we have 2.01 meter guys? Very unlikely, but it is possible. Can I have 135 centimeter people due to certain diseases. There might be some people like that. Okay, but it is very unlikely, right? The highest probability is between the mean and certain let's say certain part of my distribution. Okay, where does this 0.025 and 1.96 is coming? This is my Z table. If you remember, I found 0.025 and it is minus and plus 1.96. You're going to use this level a lot. Okay, if Z normalized value, Z value is greater than this, the probability of Z being greater than this is 0.025. Probability of Z being less than 1.96 is again 0.025. Okay, so it is very unlikely to have these two situations. Okay, that means like 19 out of 20, which is this one, 19 out of 20 cases, my mean is going to be from this area. Okay, 19 out of 20 cases, my mean is going to be from this region. Okay, but it is possible that in 1 out of 5 it can be either very large or very small with respect to the mean. Okay, I hope you understand the basic idea here. Okay, so let's move on. So that's what I tried to say. Now we are coming to the confidence interval concept. This is alpha level, which we said 0.05 in the previous case, and this is what I said. The Z normalized standard normal value, Z, is between this, let's say, minus 1.96 and plus 1.96 is going to be 1 minus 0.05, which is 95% or 0.95. Okay, so now what is Z? This is the definition of normalization, right? If you remember, we did that before. This is my sample mean. This is the population mean, which I don't know yet. Okay, I'm going to do something. I'm going to estimate this one. Let's say I know this population standard deviation, and this is the sample size of my sample. Okay, how many people did I choose? How many observations do I have? It is n, root n. Okay, so this is how we normalize our sample mean. Then we will say this, instead of the Z, I'm going to write this one. How can I go from here and leave mu alone? If you think, if I multiply this by this one, so I'm going to have probability minus Z alpha over 2 times sigma over root n, x hat minus mu, and less than Z alpha over 2 times sigma over root n is going to be 1 minus alpha, right? I just multiplied this by this one and this one. Now I have x minus mu. What am I trying to find out? Mu. An interval for mu. Okay. So if you take this one to this and to that, then I'm going to have this one. Okay. Let me show you finally. I'm going to have mu is going to be between my sample mean minus this Z alpha over 2, which is 1 minus 1.96 for 95% confidence, 1.96 again for 95% confidence, and then my mu is going to be between x hat, which is the estimate that I have, and this is x hat minus Z alpha over 2 times sigma over root n. This is x hat plus Z alpha over 2 sigma over root n. Okay, this is the lower bound, this is the upper bound. and I'm going to say I am 95% confident that this mu population mean is in this interval. Okay, is that clear, guys? I have Z. Now I say that my sample mean is coming from a normal distribution whose mean is the population mean and whose variance is sigma squared over n, and whose standard deviation is sigma, whose standard deviation is gonna be like sigma over root n, right? Same thing. So I hope this is understood. And what does that mean? If I know the population variance, then I can say that with 95% confidence or 90% confidence, my mu, the population mean, is going to be in this interval. That's what confidence interval mean. Okay. So arkadaşlar, let me go to it's also called Z interval. Now I would like you to work on this question right now. Let me start reading it. Health Ministry of Turkey or Turkey had determined that the mean weight of all 7-year-old boys in Turkey is 29 kilograms. A family doctor believes that 49 such boys living in a village are underfed. Yani az yemeden mütevellit biraz düşük kiloya sahipler. Okay? As one piece of evidence, the boys weighed an average of 26 kilogram with a standard deviation of 77 kilogram. Okay? This is 7 kilogram is the boys let's say, actually it is the standard deviation of the whole population. Okay, and then let's say this is the standard deviation of the whole population, and we obtained 26 kilograms as my X bar. Okay, this is the sample mean coming from 49 boys. Is this a strong evidence? Is this a strong evidence? How do you handle this question? How do you handle such a question? I have this value, which is 26. Let me talk about 196 again, 95% confidence. 7 kilograms is known, divided by root 49. And my mu is going to be 26 plus 196 times 7 over root 49. Okay. So the probability of obtaining such an interval is 95%. Okay. So mu is going to be the mu. This is 7 over root 49. Root 49 is 1, right? Standard error of the mean is 1. So my interval is 26 minus 196 times 1 and 26 plus 196 times 1. So that means it's going to be 24 times 0.04 and 27.96, which means with 95% confidence, my mu is going to be in this interval. Okay. So what was the general or mean weight of the population in Turkey for 7-year-old boys? It was 29, right? 29. So is this included in this interval? No. So that means I have a certain evidence that in this village the boys are underfed, right? The boys are the boys have lower kilograms, lower weights than the Turkish average weight for this group of boys. Okay, so this is how we deal with this confidence interval concept. Okay, let me go to the next one. This is how I say that. So this is boys in that village. Okay, so this was another quiz, midterm question or final question in previous years, guys. So what did I do? I found the sample mean, number of boys in my sample. I know the standard deviation of the population in general in Turkey, and then I chose this to be 95% confidence. Okay, and then I would get a z interval for the mean between this value and this value, which is that. Okay, how do you pronounce that? We get a 95% confidence interval for the mean weight of 7-year-old boys in that village or in that town. Okay, and then we will say that the mean of Turkey is 29 from the statistical analysis, and this is not included here. So we say that we have strong evidence against strong evidence that this group of in this village, the boys are less heavy or are underfed, if that's the statement that we want to make. Okay. Arkadaşlar bu konu anlaşıldı mı acaba? Okay.
Hocam,
Yes.
can we solve this question by finding a z value, not in terms of z interval? By finding z value, then we should use significance level.
Exactly. It's also something that we will mention very soon. But here the main concept is confidence interval. That's why I'm solving it in that manner, Süleyman. But as you mentioned, if we do this, z is equal to x hat minus mu divided by sigma over root n, and write 26 minus 29 divided by 7 over root 49, which is this, and z is going to be 3, and you're going to say that for z is equal to 3, the probability is very low. Okay, the p-value is significantly lower than 0.05. That means this population, this boys in that village, is highly statistically significantly different from the population in general Turkish population. Okay, again, we are going to do the same thing, and we did similar questions last week, but here I wanted you to understand it is also possible to say that to solve this problem from a different perspective. Here I would like to say the mean of this the boys in this village, the mean weight of the boys in this village is in this interval with 95% confidence. Okay, this is a different way of dealing with the same problem. So I am trying to find out, I have 49 boys in that village as a sample, but normally, let's say, or not village but town, I have, let's say, 5,000 boys in that age, and then I only got 49 samples, and I'm trying to find out what the mu value for these boys in general. Okay, that's a different kind of question. Then we can say that this is the confidence interval is in this in this range. Arkadaşlar, is this clear? Is this part clear for you? Peki. So we can be confident, 95% confident that the mean weight of 7-year-old in that village or in that town is between 24 and 28 almost, okay? And this 29 value is not included in this interval, so we may say that there's a convincing evidence that they are underfed or they are less, they have less weight. Okay, this is something that we do. Arkadaşlar, let's think about this confidence interval concept. Okay, we said that our confidence interval, or it's going to be like x hat minus z alpha over 2 sigma over root n, and then plus z alpha over 2 sigma over root n. Okay, that's my confidence interval. What happens if I increase the value of 49 to 100? And going from 49 to 100, what happens to the confidence interval? What happens to the confidence interval? So this sigma over root n was 7 over 7, which is 1. Now it is
Decrease, right?
7 over 9. It's going to be 0.7. So this value will decrease, right? This value will decrease. So it will be a narrower confidence interval. If I have more values, do you remember the video that I shared with you? I hope you watched it. Stephen Curry and another basketball player from NBA, they had different three-pointers, and then one of them has many shots, the other one has lower shots but higher percentage. So that thing explains the confidence interval concept very nicely. If you have more samples, you will be more confident about your mean, population mean, okay? That's one thing, okay? More samples mean the interval, confidence interval will be narrower. If I say z alpha is not, this was 0.05, now I want to change it to 0.1. Okay, alpha is increased. What does that mean? How does this affect my confidence interval? Now, what does it mean? This is my mu. Alpha was 0.025 here. Now it is 0.5, right? 0.5 is here. 0.5 is here. Okay, so the z value, will it be higher or lower? Here, with this, let's focus on this part. This was 196 for 0.025. Now it is larger. So what is the z value? Is it lower or higher?
Lower.
It's going to be lower value, right? Let's say 1.67, okay? I'm just making it up. It's going to be a lower value. Now, the z value, z of alpha over 2, will be lowered. So this will be smaller. This will be smaller. So I will have a narrower confidence interval, will be narrower. What does confidence interval being narrower mean? Why is it important to have a narrower mean, arkadaşlar? Narrower confidence interval. Yes, I will have, Ahmed says, more accurate result, more accurate estimation. Okay, my estimation says that it's going to be in this interval, not a big interval like that, but a smaller one. So my estimate is going to be much more accurate, right? So that means if I increase my sample size or decrease my confidence, I may have narrower confidence intervals. But here is the trick. You say I'm 90% confident that the mean weight is between this and that, which is a narrower thing, but my confidence level is low. Okay, 90%. So there might be some cases where I may miss or have higher or like higher or very low values. Okay, so I want you to understand this confidence interval in those terms. Like 95% confidence means that we'd expect 95% or 950 of 1000 intervals to be correct. That is to contain the actual unknown value of mu. We are trying to determine the mu, and I may have different x bars. Out of 1000 such x bars, 950 of them will include the mean correctly. Okay, that's what 95% confidence interval mean. Okay, I hope this is clear. And then we usually use 95% of the intervals, but in the project you're going to use different levels, 90, 95%, and 99%. And I want you to see the difference between them and comment on them. Okay, that's how we need to do. Okay, intervals length, I talked about that. Length is all about this, and if we change sigma, if we change n, or if we change the alpha value, the length of my confidence interval will change, will either be narrowed down or will be larger. Okay, larger is not something we want. Okay, something we want because we want to have a better estimate, but either we need to increase the number of samples in my hand or I need to decrease my confidence. Yani %90 ihtimalle bu aralıkta demekle %99 aralıkta bu %99 ihtimalle yani %99 eminim bu aralıkta demek arasında bir fark var. Ama %90 eminim deyince daha dar bir aralık, %99 eminim deyince daha geniş bir aralık verme durumumuz söz konusu oluyor. Şimdi we talked about these. For example, if it is 90% confidence, then z is 1.645, which is like 1.96 for 95% confidence. As I mentioned, z is 1.96 when it is 0.025. It is 1.645 when it is 0.05. That means 90% interval. Why do I say 0.05? Like 0.05 is here, 0.05 is here, so it is 10%, and the remaining here is 90%. Okay? So, until now we talked about these. Now I want you to tell me, here are the concepts that I would like to ask. With the first question, what is the goal here? What is the goal here? What am I trying to do with all these? Okay, Serhat, Enes, Ahmet. The quiz is coming. The next question is the quiz question. We are trying to estimate an interval for the population mean, right? We are trying to estimate an interval with a certain confidence level for our population mean. Okay, so what happens to the length of the confidence interval if we increase the sample size?
Is this quiz hocam?
No, not yet. It's coming. Okay. How about what happens to the length of the confidence interval if we increase the value alpha from 0.05 to 0.10? So the goal is to estimate an interval that includes the population mean with a certain confidence level. Okay, that's the goal of confidence level, confidence interval concept. How do I, if we increase n, sigma over root n will decrease, and then the confidence interval will be narrower. If we increase sigma alpha from 0.05, alpha z alpha over 2 will increase, will decrease, sorry, will decrease, so it will be again a narrower confidence interval. Okay, so now here is the problem about error. Okay, confidence interval length is this, as we discussed. This is my sample mean. This is lower bound, and this is upper bound. And I would like to find out the error. What is the maximum error that we might have?
Half of the length hocam.
Half of the length, right? Exactly. If we have x bar as my mean, sample mean, and this is my population mean. Bu ikisinin arasındaki fark anlaşıldı değil mi? Sample mean ve population mean arasındaki fark. Easy, right? So
Yes,
what's the maximum error that I can get? Mean is going to be either here or here, right? So it's the mean, the error will be this, like this amount. The maximum error that I would like to have is this amount. Şimdi burayı bir okumanızı istiyorum. If x bar is used as an estimate of mu, we can be 95% confident that the error will not exceed a specified amount E when the sample size is this. How can I use this concept in a practical application? How can I use this concept in a practical application? Arkadaşlar, we have this value sigma, we have this z. Okay, we say that I want to make an estimate with 95% confidence. And the standard deviation of my population is, let's say, 7 kilograms. And I want to have this much error. Maximum error should be 1 kilogram. Okay, I want to estimate such an error with 95% confidence with 1 kilogram error. Okay, how should I choose n? I'm going to go and say n is equal to 196 times 7 divided by 1 squared, right? This is going to be around 14 squared. Let's say 14 squared is 196, around 200. If I have 200 samples in my hand, then I'm going to be able to say, this is my sample mean, let's say 26. It should change between 25 and 27, okay? But this n is going to determine our confidence intervals size, right? So the error, possible error in estimating the mu is all depends on your n, and you can limit the problem. You can limit the error by choosing a certain sample size. Is that clear, guys? We want to limit the error. We want to limit the error by choosing a certain E value, which is 1 kilogram or 2 kilograms, something like that. And then how many data points should I have in order to have this error? That's the main question in this part. Okay? The error will be maximum here, the mean will be here or here with 95% confidence, and the error will be mu minus sigma, okay, which is this value. And then now I want to limit my error by adjusting it or assigning it a value, 1 kilogram, 2 kilograms. It all depends on your tolerance, okay? You want to minimize the error, or you have certain other limits, then you can determine what your size should be like, okay? For example, if you want to have 2 kilogram error, then it's going to be 2 times, it's going to be 7 squared, it's going to be almost 50 or 47, right? The error, if it is 2 kilograms, that means the interval will be between 24 and 28 if I have around 50 boys in my sample. Okay? Burası anlaşıldı mı acaba arkadaşlar? Yani I can limit the error, and in order to limit my error, how should I choose the number of people, the number of data points I should use in my estimation? Okay, so let's move on. This is going to be the last topic that I'm going to be discussing today in this session. So, arkadaşlar, now I want you to determine. Here is the quiz question. Okay, quiz question is coming. I have like the height of. Let me check whether we have, yes. Okay, I have this data, okay, from like six-year-old girls. There are 16 samples from this 6-year-old girls thing, and their heights are this 118 centimeter, 115 centimeter. Let me tell you, and mean is sample mean, actually. Sample mean is 118, let's say 118 centimeters, okay? And sigma is going to be 10 centimeters, okay? Now, I want you to find out with 95% confidence for the average height of 6-year-old girls in Kayseri. Okay, you have the data, 16 data, and the mean is calculated as 118. And we know that from our previous knowledge that sigma of the population is 10 centimeters. And I want you to find out the confidence interval. I don't just want the answer, okay? I want you to tell me how you found it. Okay, in the chat, please write your answers. This is going to be the quick record. So let me mention once again. In T interval, we don't know the sigma of the population. We don't know the standard deviation or variance of the population. What do? We estimate our standard deviation from our data. Okay, estimate the mean, okay, sample mean, estimate sample mean, and we estimate sample standard deviation, which is S, sample standard deviation. We are going to use this X bar and S instead of sigma. We are going to use S, okay, for the T interval case. If I don't give you the population standard deviation, then you will immediately think that, oh, I should calculate everything from my data. Okay, how do I do that? I'm gonna calculate it. Okay, find the data. I have this data set, and I'm gonna do a standard deviation and mean calculations from my data using MATLAB, using Python, anything you want. Okay, then I'm gonna come and put this S here, the standard deviation S here, the number of data samples N here, and then we're gonna find out a T value. Okay, T value. What does T value mean? Here is a kind of table that I'm gonna be giving you. It's called T table. In T table, what's the difference between Z table and D table? We have a degrees of freedom. Okay, degrees of freedom. That means this is the Z distribution. The T distribution will change with respect to the number of samples I have. Okay, for example, in the previous 7-year-old, 6-year-old girls question, we had 16 samples. We are going to say, I'm going to use degrees of freedom is 15. Okay, degrees of freedom is going to be n-1. Okay, so if I have 16 samples, my degrees of freedom will be 15. So how am I going to find out the value, the critical value for the T interval? I'm going to go and say, okay, this is 0.05 is one tail, 0.05 is the two-tail case, and I have 15 people in my group, so this is my T value. If I increase it to 30, okay, it's going to be something like that, right? So same thing, it's going to be around 2 point something, right? 2.042. So it will be decreasing as I increase my n. Okay, so here is the T 0.025, 15. This is number of samples in my data -1. Okay, and then I'm going to get this from my T table. For example, for 95% confidence, this is 2.1314, and this is my mean from my data. Again, from this data set, I found my mean to be 118.44. I found my sample standard deviation being 5.66, and I'm gonna come and put all these here. This is X bar, this is T 0.025, 15, n-1, and then this is gonna be my S, this is gonna be my N, right? So the area, the confidence interval is this or this. Okay, guys? So between Z interval and T interval, there is no major difference. The only difference is that I have a T table, not Z table. My sigma is not given. Okay, so here is the thing. I have these two intervals. This is the T interval. This is the Z interval. If sigma is not known, I use this, is not known. If sigma is known, I use Z interval. And then how do I calculate S from my data? Using a function for that. It's easy, okay? And then you're gonna check the table like that, and degrees of freedom will be on this T table, and you're gonna be choosing it as n-1, okay? So in order for you to come up with a T interval, we're gonna say X bar plus and minus T alpha over 2 n-1 S over root n, okay? So this is all about the Z interval and T interval. Please check these in practice. I'm gonna upload this slide set right now in the OneDrive part, and I want you to read this and then try to use it for your projects also. If you have reasons to believe that the data are not normally distributed, then make sure you have a large enough sample, which is like greater than 30, generally suffices, but recall that it depends on the skewness of the distribution. And I want you to focus on this and understand what's going on in that case, okay? If that data is not normally distributed, you have a small sample, you can use this one, but you have to be very careful. That's what Mustafa Berke was asking in the beginning. You have to make sure your data is normally distributed or not. You can check that using different methodologies, QQ plots or Kolmogorov or those Shapiro-Wilks kind of tests. You can find them everywhere you want, okay? So this evening we will start talking about if we have an interval like one sample data, and tonight I'm going to talk about if we have two data related to each other, and then how can I find the T values or something like that, okay? That's all for today. I hope to see you at 7:30 in the same link today, okay? Tonight we are going to meet again. We will have another quiz, inshallah, tonight. Okay, see you. Have a nice Juma, nice day.
See you. Have a nice day, Hocam.
See you hocam. See you.